Imagine a shadow slipping through the stars, silent, unstoppable, racing toward us at a speed that makes our fastest machines look like they're crawling. Now picture a quantum AI, built by the brightest minds, sifting through telescope images of this thing, something called 3IATLAS. It's not just a rock. The AI's spitting out patterns, strange signals buried in the data, screaming one thing: this isn't natural. It's moving too fast, too precise, like it's been watching us, waiting to be seen. This is our third visitor from beyond the solar system, and what Google's quantum brain found in its path confirms our worst nightmare. We might not be alone, and whatever's out there could already have us in its sights. What if the stars aren't just watching? What if they're hunting? It all started on a quiet morning, July 1st, in the chilly mountains of Chile. Astronomers were sipping coffee, staring at screens filled with the usual cosmic chatter from the ATLAS telescope. Just another day, cataloging specks of light in the endless night. Then something flickered, a tiny glowing dot that didn't belong. It wasn't just drifting like the asteroids or comets we know. This thing was tearing through space at 130,000 miles an hour. To give you a sense of that, picture a plane taking 6 hours to fly from New York to Los Angeles. This visitor? It could do it in 67 seconds flat. By the time they zoomed in, it was already inside Jupiter's orbit, about 327 million miles from Earth, and closing fast. Right now, as you're hearing this, it's brushing past Mars, like a ghost slipping closer to our doorstep. They named it 3I/ATLAS, the third interstellar object we've ever spotted, following two others that shook the world: Oumuamua in 2017 and 2I/Borisov in 2019. But this one's different. It's not just a wanderer passing through. It's massive, 6 to 9 miles across, the size of Manhattan Island tumbling through the void. Imagine that. An entire city's worth of rock or something else, hurtling toward us from the depths of the galaxy. And here's the kicker. We didn't see it coming until it was almost too late. It was hiding in a bright patch of stars, a dense corner of the galaxy that masked its approach for years. By the time we caught it, there was no chance to send a probe, no time to chase it down. It's like it didn't want to be seen until it was ready. That morning, the astronomers' jaws dropped. Within hours, NASA's best minds were burning the midnight oil, crunching numbers, double-checking data. The math didn't lie. This thing came from beyond our solar system, from the vast darkness between the stars. But what sent chills down their spines wasn't just where it came from. It was how fast it was moving and how big it was. At 36 kilometers a second, it's twice as fast as most things in our cosmic neighborhood. Even Voyager 1, humanity's speediest spacecraft, looks like it's standing still next to this beast. And its size? Oumuamua, that first interstellar visitor, was about the length of a football field, maybe 330 feet long. This thing could swallow it whole, hundreds of times over. Picture Manhattan, with all its skyscrapers and streets, barreling through space. That's what we're dealing with. But it's not just the size or speed that's keeping scientists up at night. It's the path this thing is taking. Most space rocks from other stars zip past us in a straight line, maybe bending a little under the sun's pull before vanishing back into the void. Not 3I/ATLAS. It's on a grand tour of our solar system, like a tourist checking off every planet on its list. On October 2nd, it'll skim past Mars, just 17.5 million miles away, a close encounter in cosmic terms. Then, on December 19th, it'll swing by Earth about 167 million miles out, far enough to stay safe but close enough to get a good look. After that, it's off to Venus, passing just 60 million miles away, and then it'll loop toward Jupiter in 2026, grazing within 33 million miles of the gas giant. This isn't random. Scientists ran the numbers, and the odds of an object naturally hitting all these marks? Less than 0.005%. In other words, in 99.995% of cases, a stray rock from another star would just sail past, ignoring our planets entirely. But this one? It's like it's been choreographed, a cosmic dance with no visible dancer. That's where the quantum AI comes in. Google's machine, built to spot patterns too subtle for human eyes, dove into the telescope data and started flagging things that made astronomers' hearts race. The path wasn't just unlikely, it was too perfect. A Harvard professor, Avi Loeb, and his team spent weeks picking apart the trajectory. They called it a grand tour route, the kind we'd design if we were sending a probe to study alien worlds. It's not just passing by, it's positioned to scan Mars, Earth, Venus, and Jupiter, each flyby calculated to gather maximum data while staying just out of reach. And here's the part that makes your skin crawl. When it reaches Earth on December 19th, it'll be on the opposite side of the sun, perfectly lit up for observation. But the sun will block our view, making it nearly impossible for us to study it closely. Loeb didn't mince words. This could be deliberate. Something that wants to see us without being seen. Now, let's pause and let that sink in. What if this isn't just a rock? What if it's a probe, a machine sent from another star, following a path so precise it feels like it was planned? The AI's simulations didn't just confirm the path's strangeness. They hinted at tweaks, tiny adjustments that suggest something or someone might be steering it. And if that's true, why avoid us? Why swing closer to Mars, 10 times closer than to Earth, as if it's keeping its distance? Loeb's team had a chilling thought. Maybe it's not here for us. Maybe it's studying our whole system, cataloging our worlds like a collector sizing up a prize. Or maybe it knows we're here, and it's staying far enough away to avoid trouble, ours or its own. The timing adds another layer of mystery. Calculations show this thing crossed into our solar system about 8,000 years ago. That's when humanity was just starting to build cities, invent writing, and light up the Earth with the first sparks of civilization. Could our early fires, our first steps into something bigger, have caught someone's eye across the stars? The thought is thrilling, but it's also terrifying. Because if this is a probe, it didn't just stumble across us. It's been on its way for millennia, and now it's here, weaving through our planets with a purpose we can't yet grasp. Let's step back for a moment, to a time when the stars first whispered something strange. 8 years ago, in 2017, a telescope in Hawaii caught a glimpse of another visitor, a ghost from beyond our solar system called Oumuamua, Hawaiian for messenger from afar, arriving first. It was our first taste of something interstellar, and it left us with more questions than answers. That fleeting shadow set the stage for what we're facing now with 3IATLAS, because the similarities are too eerie to ignore. It's like a story unfolding across the years, each chapter darker, each clue pointing to something we're not ready to face. What if Oumuamua wasn't just a scout? What if it was the first signal, paving the way for the massive traveler now weaving through our planets? Picture Oumuamua as it appeared back then, a faint speck racing out of our solar system before we could get a good look. It was moving fast, 54 kilometers a second at its peak, 5 times faster than Voyager 1, 11 times faster than SpaceX's Starship, 250 times the speed of sound. It came close to the sun, just 23 million miles away, a scorching pass that should have melted anything ordinary. Comets, when they get that close, burst into life, spewing glowing tails of gas and dust as the sun's heat boils their icy surfaces. Not Oumuamua. It sailed through, silent, showing no tail, no trace of evaporation, like it was made of something we couldn't even imagine. Its shape was stranger still, either long and thin like a cigar or flat like a pancake, nothing like the round, rocky bodies we know. And then, the real puzzle, it sped up. 40 days before we spotted it, after its sun-skimming flyby, it gained speed in a way no comet should, with no visible jets of gas to explain the push. Something gave it a shove, and no one could say what. Back then, scientists scrambled to make sense of it. Some said it might be a chunk of frozen nitrogen, broken off a distant Pluto-like world, melting just enough to nudge it along without a visible tail. Others thought it could be a comet transformed by eons in deep space, its water ice turned into hidden hydrogen by cosmic rays, escaping in tiny bursts when the sun warmed it up. But those explanations stretched thin against the data. Oumuamua was about 377 feet long, 364 feet wide, roughly a football field, big enough for complex equipment, small enough to zip through stars. It looked like what we'd build if we sent a probe to another system. sleek, efficient, built to observe and report. When it left, vanishing into the cosmic dark, it felt like a missed chance, a message we couldn't decode. Now, fast forward to 3I/ATLAS, and the echoes are deafening. This new visitor, hundreds of times bigger, is following a path that feels like a sequel to Oumuamua's strange visit. The 8-year gap between them is chillingly precise. Just enough time for a scout to send a signal across the stars, and for something bigger to follow. If Oumuamua was a recon probe, small and stealthy, 3I/ATLAS could be the main event. A command vessel, a mothership, designed to study our system up close. Its size alone, 6 to 9 miles across, suggests something capable of carrying far more than just cameras and sensors. And its path, that impossibly perfect loop through Mars, Earth, Venus, and Jupiter, mirrors the kind of mission we'd plan to map out an alien world. The quantum AI's simulations only deepen the mystery, showing tweaks in its trajectory that feel less like chance and more like intent, as if something's guiding it to watch us without getting too close. This is where the fear creeps in, the kind that keeps you staring at the ceiling at night. There's a theory out there, born from a question asked decades ago by a physicist named Enrico Fermi. If the universe is so vast, teeming with stars and planets, where is everybody? Why haven't we seen signs of intelligent life? The dark forest hypothesis gives a chilling answer. Imagine the universe as a shadowy forest, full of life, but every creature stays silent, hiding in the dark. Why? Because making noise, showing yourself, could draw the attention of a predator. Civilizations, this theory says, learn fast to stay quiet or risk being found by something stronger, something that sees you as a threat to crush or a resource to take. If 3I/ATLAS is a probe, its presence screams one thing. Someone out there has technology light years beyond ours. They can cross stars, weave through planets with pinpoint precision. That kind of power doesn't just mean advanced engines. It could mean weapons, tools, things we can't even dream of. The AI's readout, flagging those deliberate patterns, feels like a warning. We've been seen, cataloged, maybe judged. What's worse is the timing. That 8,000-year journey of 3I/ATLAS lines up with when humanity started to shine. 8 millennia ago, we were building our first cities, scratching out the first words, lighting fires that could be seen from space. Did those sparks catch someone's eye? Did our first steps into civilization send a signal rippling across the galaxy, drawing this massive visitor to our doorstep? The thought is both thrilling and terrifying. If this is a probe, it's not here by accident. It's here because of us. But why stay so far from Earth, passing 10 times closer to Mars? Maybe it's not interested in us directly. Maybe it's studying our whole system, sizing up our resources, our defenses, our potential. Or maybe it knows we're here and is keeping its distance, watching from the shadows, deciding what we're worth. And here's the part that twists the knife. It might not leave. Scientists say 3I/ATLAS could use Jupiter's gravity in 2026, or even the sun's pull, to slow down and slip into an orbit around our system. We do this with our own probes, using planets like slingshots to tweak their paths. If whoever sent this thing mastered interstellar travel, they'd know those tricks better than we do. Imagine it settling in, a silent watcher circling our worlds for years, decades, maybe centuries, studying us while we scramble to understand it. The quantum AI simulations hint at this possibility, showing how small course corrections could lock it into place. Every time we look up, we'd wonder, is it still there, waiting, watching? But not everyone's convinced this is a visitor from another world. As 3I/ATLAS races closer, scientists are locked in a fierce debate, torn between awe and reason, trying to pin down what this thing really is. Some look at the data, the faint glow, the whisper of a dust tail, and say it's just a comet, a massive one, sure, but nothing we haven't seen before. Others, staring at that impossibly precise path, feel a chill they can't shake, wondering if we're looking at something built, not born. The quantum AI's simulations, with their unsettling patterns, have only fanned the flames. It's a tug of war between hope for a natural explanation and the creeping dread of something far stranger. And as the clock ticks down, with 3I/ATLAS barreling toward its closest brush with Earth, we're running out of time to decide what we're facing. Let's start with the skeptics, the ones clinging to the familiar. They point to the object's faint glow, what astronomers call a coma, forming as it nears the sun. That's classic comet behavior: ice warming up, turning to gas, reflecting sunlight in a shimmering halo. They've even spotted a faint dust tail in specialized images, barely there but growing, the kind you'd expect from a giant icy rock waking up under solar heat. To them, 3I/ATLAS is just an oversized comet, kicked out of another star system by some long-ago gravitational tug. They lean on examples we know. Comet Hale-Bopp, lighting up our skies in 1997, was 46 miles across. The Bernardinelli-Bernstein comet, found in 2021, stretched an astonishing 85 miles. From that view, 3I/ATLAS at 6 to 9 miles wide isn't even a record breaker. It's rare, sure, but not impossible. One astronomer, Samantha Lawler, puts it plainly. Comets get ejected from star systems all the time, billions of them wandering the galaxy. We've only seen 3 because our telescopes aren't good enough to catch the rest, not because they're hiding. They've got theories for Oumuamua too, that strange first visitor from 2017 that set this whole mystery in motion. Some, like Alan Jackson and Steve Desch, say it was a chunk of frozen nitrogen, snapped off a Pluto-like world, melting just enough near our sun to speed up without a visible tail. Others, like Daryl Seligman and Jennifer Bergner, argue it was a comet, its water ice morphed by cosmic rays into hydrogen over millions of years, escaping in tiny jets that pushed it faster with barely a trace. These ideas stretch to 3I/ATLAS, painting it as a natural oddball, not a machine. The glow, the dust, the ice. They're all signs of a comet doing what comets do, just on a scale that makes our jaws drop. But there's a problem, a nagging detail no one can fully explain. That trajectory. The odds of an object naturally weaving through Mars, Earth, Venus, and Jupiter in such a perfect loop are less than 0.005%. That's not just unlikely. It's like winning the cosmic lottery. Even the skeptics feel the weight of that number, a whisper of doubt that keeps them up at night. On the other side, you have those like Avi Loeb who look at that path and see something more. The quantum AI's simulations back him up, showing patterns that feel too deliberate, too engineered. It's not just the route, it's the timing. When 3I/ATLAS swings by Earth on December 19th, it'll be lit up perfectly by the sun, ideal for scanning us. But the sun will sit right between us and it, blocking our best telescopes. That feels like a dodge, like something playing hard to get. And the possibility it could slow down, using Jupiter's gravity in 2026 to settle into an orbit, makes the stakes even higher. If it's a probe, it's not just passing through. It might be here to stay, watching us for who knows how long. The connection to Oumuamua only deepens the unease. That smaller, faster visitor, with its odd shape and unexplained speedup, looked like a scout. Now, 8 years later, here comes 3I/ATLAS, hundreds of times bigger, following a path that feels like the main act. The AI's patterns suggest they could be linked, part of a coordinated effort to study us, starting when our first cities rose 8,000 years ago. Now, astronomers are in a desperate race. Every clear night is a gift, telescopes around the world swiveling to track this speeding giant. They're capturing light, spectra, rotations, anything to unlock its secrets before it's too late. When it hits that December close approach, the sun's glare will blind us, cutting off our best chance to see it clearly. Unlike Oumuamua, which we only caught on its way out, 3I/ATLAS is still coming, giving us a narrow window to study it at its brightest. But it's not enough. Our tech can't keep up. Sending a probe to meet it? Impossible with its speed and our rockets. The European Space Agency has a Comet Interceptor planned for 2029, a craft that'll wait in space for the next visitor, but it's too late for this one. If we'd spotted 3I/ATLAS just 1 year earlier, we might have launched something to touch it, sample its surface, settle the debate, rock or machine. Instead, we're stuck watching from afar, piecing together clues from millions of miles away. The frustration is palpable. Scientists are poring over every scrap of data, knowing this might be our only shot for decades. Each photo, each measurement, adds to a puzzle that could outlast us all. The quantum AI keeps crunching, its simulations pointing to that haunting precision, but it can't answer the big question. Is this a comet, or is it something staring back? The dark forest looms large in our minds. The idea that the universe is full of life, but only the silent survive. If 3I/ATLAS is a probe, its makers are light years ahead, their intentions a mystery. Are we too small to notice, like ants under a giant's boot? Or are we a threat, something to be studied before we grow too strong? The AI's warning, those patterns in the data, feels like a spotlight turning our way. And as 3I/ATLAS dances through our system, we're left wondering, is this the moment we realize we're not alone? Or the moment we learn we've already been found?